Hey everyone, we are going to learn about trigonometry today. So I'm going to show you my document camera, if you will. Let's see here. We're going to use this and learn about trig. Okay, so this triangle, I know it's a little tiny bit blurry, but we'll just make do with what we have. On this triangle, you can see, or there's three triangles here, and I tell you down here that triangle ABC is similar, that's what that symbol means, we didn't talk about that a lot, to triangle DEF, which is also similar to triangle GHI. So these three triangles are basically just a dilation or an enlarged version of the other, okay? Also, you can see on here, maybe, this side right here, this is 3, this length is 4, and this length is 5. So hopefully it makes sense to you that this triangle is just twice as big, with this length being 6, this length being 8, this length being 10. Don't worry too much if you can't see those numbers. I will try to get it a little bit clearer. Sometimes this works really well and it's not blurry at all. And sometimes it's just really blurry, so I'm sorry. Okay, anyway, so then we have this one that's 6, 8, and 10. So this triangle is just twice as big as this one, but it will still have the same angle measures. The side lengths are just doubled. And then on this one turns out to be 3 times as big as triangle ABC. So we've got a 9, a 12, and a 15. Okay, so there are some important ratios that we are going to use. And specifically, I named these ones down here, and we're going to fill in the blanks for the other triangles. So if we have the ratio AB over AC, then that's talking about the relationship between this, I would call this the long leg, to the, do you remember what this is called from back in your probably 7th or 8th grade? That's called the hypotenuse, the one that's across from the right angle. So this would be like the long leg over the hypotenuse. So let's see if we can find those two sides of this middle triangle. So the long leg would be this DE. So DE over the hypotenuse, which would be DF. And then in that third triangle, this is triangle GH. Sorry, you know, you can't read that very well. GHI. The long leg of GHI is the GH. And the hypotenuse of that triangle is the side GI. So hopefully it makes sense to you that this is a true proportion, because AB over AC would be the length 4 over 5. In the middle triangle, DE over DF would be 8 over 10. And in the big triangle, 12 over 15. And all of those, if we were to stick any of those into our calculator, we would get the value 0.8. Okay. Then there's this second set, and we're going to go through this one a little bit quicker so we don't get too bored and the video doesn't drag on forever. So it's BC, which I would call the short leg, over AC again, the hypotenuse. Okay, so we're gonna do short leg EF over hypotenuse DF. And those of you that did the similarity and proportions assignment, you actually might realize we could just grab those from right here. If I want to compare BC to its corresponding side on those other two triangles, BC is the second and third letter. So I would use EF and I would use HI to match up with BC. Okay, and then I have AC, the hypotenuse. So that would be AC is the first and third letter. So DF, which we already have, and then GI would be the hypotenuse of the big triangle. And again, with numbers, BC is a 3. I know you can't read it very well, but that is a 3 over the hypotenuse, which is 5. EF is 6 over a hypotenuse of 10. And finally, 9 over 15. If you throw those in a calculator, you get 0.6. Okay, last one, BC, short leg over AB, long leg. Okay, so that's going to be EF over DE, so short leg over long leg, and then IH, no, HI, I guess is the way I wrote it before, so HI over GH. And with numbers, one more time, BC is 3 over AB, which is 4, so 3/4. Then we would have 6/8. Then we would have 9/12. And in decimal form, we get 0.75. Okay, so now the reason I picked these particular pairings, I guess you could say, is because these correspond to what we call trigonometric functions. Okay, so these trig functions are going to be super important for you. The reason we had to learn this before school is over is because these are going to be a critical part of learning math next year. So we wanted you to have just a little bit of a foundation this year. So in order to talk about the trig functions, I want to ask you this question. Which is, how do we explain which sides we just use in our ratios? Okay, so how do we explain to someone, so I kind of referred to those sides as the short leg and the long leg, but maybe there's a better way. So that we're going to talk about that better way right now. So we're going to actually describe where a side is by comparing it to where an angle is. So that means every time I do one of these trig questions, trigonometric questions, we're going to have a specific angle that is selected for us. Now, I chose A. I marked angle A. You could also choose angle C. But trigonometry that we're going to learn this year is all right triangle trigonometry, and we don't ever really refer to this right angle. The words that we're going to use will be confusing if you try to go from angle B because it's the right angle. So we're going to use either A or C, the two acute angles in the triangle, and I picked A for this one. Okay, so I would describe AB as being, the math word is adjacent, so that just means next to. Can you see how this side of the triangle is right next to angle A? But BC, on the other hand, is not right next to it. We would say it's across from it, but in math we call that opposite. So across from is going to be the same thing as opposite. Okay, so we're going to have AB is next to, or AB is the adjacent side to angle A. BC is the opposite side from angle A. And then we discussed earlier, AC already has a name, so we're not going to give it a new name. AC is the hypotenuse. And it doesn't matter which angle you picked, it's always going to be the hypotenuse. So really quick, let's label these triangles. If I pick this angle right here, then do you see how this side over here would be the opposite side? You definitely cannot read this. I am going to post the pictures of these documents as well, sorry. Okay, so this is the opposite side. Again, here's the angle. So this side is the side we're going to call the adjacent side. And then remembering that fancy word from when you learned about triangles a long time ago, this is the hypotenuse. Okay, let's try the other example. I'm going to use the black pen because I think the red pen is a bad choice. So again, from this angle, and maybe this time I want to start with hypotenuse. It doesn't matter how the triangle is situated. The super easy way to recognize the hypotenuse is that this box that forms the right angle is always pointing to the hypotenuse. Okay, and then from this angle, we have these other two sides. We just need to decide which of these two sides is next to the angle and which of these two sides is across from the angle. So I think this is the side that's next to it. So this is going to be called adjacent. And this side will be opposite. It is all the way on the opposite side of the triangle from the angle that we have selected. Okay, so back to our beginning. We had these random numbers. They probably seemed kind of pointless at the time. Okay, but I happen to know, just because I've been doing math for a long time, I happen to know exactly how big this angle measure is. So that will also be the same as this angle measure, and that will also be the same as this angle measure. Okay, and on those triangles, that measure of angle A, measure of angle D, and measure of angle C, those are, sorry, measure of angle G, those are all 36.87 degrees, which seems a little bit like kind of a rough number, but it will be fine. So I want to show you something actually on your calculator. And you guys might not have one of these calculators with you, but there are scientific calculators just on the internet. You can just look one up. But if you look close right here, and again, blurry picture, so sorry about that. Let's see if I can not be blurry. It just wants to be blurry. But there are three functions. There are three important buttons that we are going to use. And they are going to be these three on the end here, the sine, cosine, and tangent. So it looks like sin, cos, tan, but we actually say their full word even though they are abbreviated. So those are sine, cosine, and tangent, and those actually come from the math that we just did in here. So our math in here, we were talking about these particular ratios. And if we go back and look at that other page, we're talking about adjacent side over hypotenuse. And then on this one, we are talking about BC over AC, which would be the opposite side if I'm coming again from angle A. That would be opposite over hypotenuse. And then that third one, if we look close, we have BC over AB, which again would be that opposite side, but over the adjacent side instead of the hypotenuse. So opposite over adjacent. Okay, so I'm going to show you what happens when I push a particular button on my calculator. Actually, maybe let's do this. Show you just an example. If I just ask for a scientific calculator, and then this is going to be important on a scientific calculator. There are two options. This one, RAD, is called radians. This one is in degrees. DEG is degrees. We want to be in degrees. Okay. If I push cosine, and I told you that angle, and this is not something you needed to know, but that angle that we have in that picture is 36.87 degrees. That number right there is really close to 0.8. Okay, so go back for just a second. Do you remember how we had a 0.8 right here? Okay, and I just pushed, if we go back to me again. I just pushed cosine of that angle and it gave me that 0.8 or something super, super close to it. So what I am suggesting now is that this I don't know why it won't let me look at that one now. There we go. Okay, this 0.8 and this ratio of adjacent over hypotenuse, this is a new function called the cosine function. We usually abbreviate it with just COS because that's what it has in your calculator as well. All right, then we could do the same thing with sine. Okay, if I switch and share my screen again, I can type in sine of 36.87 degrees. Oops. And that is 0.6. And that 0.6 is right here. Okay, and you will notice the same thing will happen if I type in tangent. So tangent is going to give me this 0.75 that I have right here. Okay, so we have 3 trig functions that you need to learn this year. We have the cosine, right here, cosine, sine, and tangent. And it's important to know which ratio is which. And I have included here this variable. This is a variable that we use when we're talking about angle measures. So we use X and Y when we're doing algebra, but when we're talking about angle measures, we use Greek letters. This is the Greek letter theta. Okay, so cosine of theta, any angle theta from a right triangle is going to be the ratio of the adjacent side of that triangle, or the adjacent side to that angle, over the hypotenuse of that triangle. The sine is going to be the opposite over hypotenuse in that triangle, again coming from that particular angle theta, whichever one is marked. And then tangent is going to be the opposite over adjacent. So just a really quick example. Oh, and I included down here, sometimes it's helpful to have some sort of a memory device to remember which one is which. And most of the time when we talk about these, we usually talk about sine first, cosine second, and tangent third. Not that it really matters, but the mnemonic device works that way. So Pocahontas, once upon a time, had a best friend, and Pocahontas's best friend's name was Sokotoa. And we use Sokotoa to help us remember that sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. Some of my students really like this one, but another one that is a crowd favorite is that some old hippie caught another hippie tripping on acid. And if you can remember those words, then you can remember these letters, and that will help you keep straight which one is adjacent over hypotenuse, opposite over hypotenuse, and opposite over adjacent. So one more time, some old hippie caught another hippie tripping on acid. Okay, so really quick, let's do some examples and then we will end this very lengthy video. So over here I have this triangle. Again, sorry about the blurriness, but we've got a 5, a 12, and a 13. If I am asked to find the sine of angle theta, and angle theta is sitting right here. Sine of angle theta, if you remember over here, sine is the opposite side over the hypotenuse. So opposite from angle theta is 5. The hypotenuse of this particular triangle is a 13. That's my answer. That is what it is looking for, is that ratio of 5 over 13. So cosine would be the adjacent side, which is that 12 over the hypotenuse of 13. And then tangent will be opposite over adjacent, which gives me 5 over 12. One more example down here. If I want, in this particular triangle, the sine of angle theta, sine, again, we've got opposite over hypotenuse. So from the theta, I go opposite, that's a 24. Over hypotenuse, again, the right angle symbol is pointing to that hypotenuse, so that's a 25. Cosine is A for adjacent. The adjacent side is that 7. The hypotenuse, 25. And then last one, the tangent is equal to the opposite side over the adjacent side, or 24 over 7. Okay, hopefully that video will help you get going on that math assignment. I will also post images of these notes pages that I was using so you can actually see them clearly. Have a great day.